Welcome back, students. Chapter 2 is pretty much all done. As far as theory is concerned, it's all done. However, I'd like to go over just one more example. What I really want to do is to solidify your understanding through one concrete and very realistic example. Here we go. The density of the Earth is known to be about 5.517 grams per cubic centimeters. Henry Cavendish, an English chemist and physicist, was the first scientist to accurately measure the density of the Earth. Here's the data set based upon his experiments conducted on 1798. And then we have 29 measurements. Now we have to answer these questions. Find the mean and sample standard deviation. Find a 5-number summary and box whiskers chart. Produce histogram. Produce a stem leaf plot. Basically, we are covering everything in chapter 2, every important thing in chapter 2 like a blanket. Furthermore, we have this remark, we have some step-by-step process how to use MS Excel to calculate all these kind of things, because you see, calculating the mean with handheld calculator would be time-consuming but not too bad. We have to just add up all these numbers, divide by 29, and we have it. The sample standard deviation, on the other hand, this is gonna be a challenge with handheld calculator. So what we do, one way is to use Mathematica. Just run this cell for data. Okay, actually we don't want variance. Run this cell for mean and the sample standard deviation. And here are Mathematica's computation. It's good. But Mathematica is difficult software to learn. Not everybody has it, and also it's expensive. So let's talk about how to use MS Excel. And I want you to save time, so I just typed in everything a priori, so everything is already there. And let's find out how to get the mean. Okay, mean. I want mean right over here, so highlight it here and go to this stat symbol sigma and click this upside down arrow to get more option and find average. And you have to select appropriate numbers to take averages. So highlight all these, click enter, and that's it. You have the mean. That was simple. How about standard deviation? That's going to be a little bit more challenging. Okay, we are here and we are going to do the same thing, get a little bit more, and some average count numbers and so on, not there, so even more functions. Now here, the default is most recently used, but you can find out statistical function out of here, especially if you're using public computer. Then among those most recently used, it's quite likely the sample standard deviation is not there, so you'll really have to do this. Statistical, okay, get it? And let's find out sample standard deviation. Let's go to standard deviation, it's in S. There are two. Standard deviation.S is the one we want, sample standard deviation. The other one is for population standard deviation, and we never use it. I didn't even tell you the formula for it. So take this one, click OK, and all you have to do is to select the numbers. Okay, that's it. Let's practice again. Go here and more functions, and among all these you have to find a statistical if it isn't set already. Statistical, and then let's go to standard deviation.s here. Click, and then you have to select appropriate cells. Okay, and there is the sample standard deviation. Does it match? Yes. 5.44793, 0.220946. Yes, they match. Now let's go over to the the 5-number summary. The lowest and highest are relatively easy to do, and one way to handle it is to do this. Highlight the entire cell here and sort. This is useful too. Sort smallest to largest. And expand the selection. If I do that, all the other rows will be affected. So unless you know what you're doing, do it this way. And here we go. The lowest is 4.88 and the largest is 5.85. And you can find out median this way by knocking off 2. Another way to handle it is to do this. Click this and then go to this and find out the lowest or the minimum. And you can select the minimum of this data set. Click enter and that's the minimum, 4.88. Maximum the same, highest is go over there and then find out the maximum. Not that cell, I want this data set. And click enter and you have the maximum. Whoops, what did I do? Okay, and then we want maximum, and I'm selecting all these. Okay, and click enter. Okay, 5.85. Median, let's find out median. Go here and then more functions. And if it is not there already, you have to find out statistical. Let's suppose you do that. And then let's find out median and M. Median, here we go. And then select the data set. Okay, that's the median, 5.46. Now, do these match? Well, let's see. What is Mathematicus computation? Minimum, okay. Median, okay. Maximum, okay, those 3 match. Now let's go over to Q1 and Q3. They are going to be a little bit trickier. First quartile, okay, let's do the same thing. Go to more functions and statistical. And let's go to quartiles, but there are 2 of them. Quartile EXC and quartile INC. The quartiles that we use in our textbook is quartiles EXC. This is a little bit easier of the 2. Select this one and then select all these. Oh, by the way, that's not enough. There are Q1, Q2, and Q3. Q2 is the same as the median. We want Q1, right? So first quartile, and that's going to be 5.295, kind of like that. Let's go to the third quartile here, and let's do the same thing. More functions, and statistical is already selected, so let's go to quartiles. Quartiles EXC, what does that mean? Actually, quartiles EXC means quartiles excluding the median. You see, if you have odd number of data, the median M can be included or excluded. If you throw it away, exclude it, and then you get lower half, and then you get the middle number there again. That's going to be Q1 EXC. Now, if you include the median and then do the same thing, then you're going to get quartiles including medians. So Q1 INC will be something like that. Let's see, what is the middle number? This is a middle number. So, and then let's change this color into something more conspicuous, like red. That's a median. Now, if I exclude this median, I'm looking at these numbers and finding out the median of this lower half. That's this one, Q1 EXC. But if I include this median, then and then find out the same median process, then you're going to get Q1 including the median Q1 INC. So there's a subtle difference between one and the other. Let's find out Q1 INC, and let's see how different they are. See, there's a subtle difference between one and the other. The first one is the median of the lower half excluding the median. That is Q1 EXC. And the second number is the median of lower half including the median. So there's a subtle difference between this and that. So how do we handle? According to our textbook, we simply take Q1 EXC, and that's the way we would like to do most of the time. According to the Mathematicas computation, however, we take the average between these two quartiles, these two first quartiles, and that's how we get 5.2975. Similarly, we get 5.6125 as the third quartile. In short, Mathematica is doing a little bit more advanced than what our textbook is doing. And either way, it's okay. But most of the time, I'll simply stick to Q1 EXC and Q3 EXC. If you use INC, you'll still get full credit as far as my exam is concerned. But I cannot say the same thing to Web of Science computation. Web of Science has its own mind, and sometimes I do not agree with that. Anyway, if you have 5-number summary now, then you can manually produce box-whiskers chart. And we have a couple of horizontal line segments that corresponds to the lowest and highest, and then draw a vertical line that join those two. And in the middle we have a box that begins from Q1 and at Q3, and we have another horizontal line at the median. That's box whiskers chart. You can manually create this with paper and pencil and ruler if you know 5-number summary. And then how about histogram? Well, I'm using Mathematica, so I can produce histogram very quickly, 4.7 to 6.0 with class interval size at 0.1. And if you want to do it manually, then you'll have to produce a frequency table. You get all those intervals, interval size of 0.1, and then count the number of measurements that falls into that and create frequency table. And based upon that frequency table, you can create histogram like this. Of course, if you use 0.1 as class interval size, then you'll have to create rather big histogram and class intervals, frequency table, excuse me. So it's going to be a little bit easier if you produce a little bit larger interval size like 0.2. In that case, you have 1, 2, 3, 4, 5, 6 class intervals. So frequency table computation will be a lot easier. By the way, if you use even smaller class interval size, I can see that this data is bimodal. It kind of surprised me because usual measurements usually follow unimodal symmetry case. Maybe it's just an artifact. I'm not exactly sure. Anyway, depending upon class interval size, we can produce different histograms. How about 7-leaf plot? Kind of like this, 48, excuse me, not 48.8, 4.88, and then 5.07, 5.10, 5.26, 5.27, 5.29, 5.29 again, kind of like this. All these are summarized here in stem and leaf plot here. By the way, stem unit is here 1/10, which means the second digit, last digit for stem is 1/10 digits, not first digit. If it is first digit, then this will be 48.8, but this is 1/10 digit, so it's 4.88, 5.07, 5.10, etc.